Hello everyone, welcome back to my YouTube channel Execute Physics. Today we are going to deal with the topic thermal physics and solve questions from 2023 question paper. So in this video I have included some questions from paper 6, paper 4 and paper 2 as well. Okay, so let's directly dig in. So first question is from paper 2. The question says a sample of gas is trapped in a rigid container. As the temperature of the gas is increased, the pressure increases. So it is a rigid container with a sample of gas. So the volume is constant in that container. And in that container with the volume constant, the temperature is increased. So what happens? The pressure also increases. So the question says which statement is not correct? So let's read the statements. The gas molecules have greater kinetic energy. The gas molecules hit the walls of the container harder. The gas molecules hit the walls of the container more frequently. And the gas molecules move further apart. So what happens when the temperature is increased? The gas molecules gain in more energy. As they gain in more energy, what happens? They move around much faster with greater kinetic energy. As they move around faster with greater kinetic energy, they obviously will hit the walls of the container harder, and they will hit among themselves as well more frequently. So what happens as they move around more faster and they hit around each other very with greater kinetic energy? What happens? The space between them decreases because they are hitting more often. So the correct answer is, that is, out of these four statements, okay, the statement which is not correct is option D. So the correct the answer for this question is option D. Moving to the next question. So what happens when the temperature of the liquid increases? So the statement is in relation with the mass, volume and density. So let's quickly read the statement. The mass of the liquid increases, making the liquid less dense. So how can the mass increase when it's just the temperature that is increased? So mass, that is the amount of matter in it, in the liquid, will remain the same even if the temperature is increased, right? So mass factor will not increase. The C and the D part says the volume of the liquid increases, making the liquid less dense. D says the volume of the liquid increases, making the liquid more dense. So what happens when the temperature is increased in a liquid? So the liquid particles gain in more energy. So what will happen if they gain in more energy? They move around much faster. They occupy more space. So what happens? We feel the volume has little bit increased. So as the volume increases, as the distance between them increases, what happens? The liquids become less dense. So the correct answer is option C. Correct answer is option C. The volume of the liquid increases, making the liquid less dense. The particles move away from each other in the liquid case. Next question. A bar of metal, which is a good thermal conductor, is heated at one end. What is the main method of transfer of thermal energy along the bar? That is vibration, movement of atoms of the metal along the bar, transfer of electrons, vibration of atoms of the metal bar. In this, out of these four statements, after these four, there are a few options which is actually correct. Lattice vibration, the vibration of atoms of the metal bar, these are all actually correct. But the main method is that the metals have the free electrons available for conduction. So as and when a heat is applied, immediately they begin to transfer. So the correct answer as the main method of transfer of thermal energy along the bar would be option C, transfer of electrons. Next is a paper 6 question. A student investigates how partly covering the top of the beaker affects the rate at which water cools. So this is an experimental study in which the student is investigating upon the rate of cooling with the lid that is being used to cover. When it is partially covered or maybe fully covered or 3/4 covered, it is a study on this particular experiment. So you can see the experimental setup. So you have a beaker with hot water and a partially covered lid and a thermometer attached to the clamp stand. So you are asked to first record and read the room temperature. Theta are shown on the thermometer in figure 1.2. This is a thermometer and its reading is shown. So before we take the reading, it is important for us to analyze how much is each division. So let's just find out. Between 10 and 20 there are 10 lines. So that makes it 20 minus 10 is 10. So 10 divided by the number of lines, 10. So each division is 1 degree Celsius. So what does it say? The reading over here, 21 degrees Celsius. So the correct answer is 21 degree Celsius is the room temperature. Next question. The student pours 100 centimeter cube of hot water into the beaker. She places lid A on the beaker. This leaves half of the top of the beaker uncovered as shown in figure 1.3. As you can see in the figure, the lid A, this is lid A, which covers the beaker only by half. Then she records the temperature of the water in the beaker and immediately starts a stopwatch. She records the temperature theta of the water every 30 seconds. So every 30 seconds she's taking the reading. Her readings are shown in table 1.1. She repeats the procedure using lid B. So this is the lid B. As you can see, 3/4 of the beaker is covered with lid B. This leaves a quarter of the top of the beaker uncovered. Only a quarter will remain uncovered. So complete the headings row in table 1.1. Complete the time column in table 1.1. So first, the time column. What is the unit of time? It is mentioned that they are making the recording every 30 seconds. So from that itself, it is clear that the time unit is in seconds. And what about theta? If you remember, the thermometer was in degrees Celsius. Each unit was 1 degree Celsius. Am I right? So the temperature is also taken in degrees Celsius. So we have to fill the headings first. Degrees Celsius. We have to fill in the units and time in seconds. So every 30 seconds it is making the readings, right? The thermometer, she is taking the reading. So let's every 0 plus 30, 30, 30 plus 30, 60, and it goes on like that till 180. So you have to fill up this table as such, and it carries 2 marks. Next question. Describe a precaution that should be taken to ensure that the temperature readings are as accurate as possible in the experiment. So in order to ensure that the readings are properly, we need to ensure that we are avoiding parallax error. That is one of the main precautions that has to be taken in any such kind of experiments. So the precaution is we have to avoid parallax error, and in a brief way, even though it's just a 1 mark question, in a brief manner you have to explain what is parallax error as well to get the full 1 mark. Okay, so what is parallax error? It is a human error that occurs due to the incorrect positioning of the eye. So if the eye should be in straight eye line contact with the reading that is being taken. If it is in if the reading is taken from up or down, it will result in a parallax error. So the line of sight should always fall in a straight line with the line of the measuring scale. So moving to the D part of the question, write a conclusion to this experiment stating for which the rate of cooling is greater. That is, out of the 2 lids, the lid which is partially covering the beaker and the lid which is covering the beaker by 3/4, in which the rate of cooling is greater. So logically thinking, we can tell that in which would be greater. The first lid, in which it is partially covered, has more space for the air molecules to move out. Am I right? So in the first case, it would be greater, rate of cooling would be greater. But you have to justify your answer with reference to the result. So if we had a tabular column as such, and this was the results, so we have to justify that the lid A had a greater rate of cooling than lid B with this result. So for that, let's take the initial temperature at 0 degrees Celsius, 80, and the final temperature at 180 seconds, it was 68. So the rate of cooling is by 12 degrees Celsius. And second lid, it was from 81 to 73, 7.5. So from this itself, it is clear that the beaker with lid A cooled down faster than the beaker with lid B. So we have to write the rate of cooling is greater in lid A within the time period of 180 seconds. The reason being, with the lid, we have to justify. Now that we do not have to tell the reason, we have to justify that with proper evidence. So the evidence is, with lid A, as in the tabular column, the temperature reduced by 12 degrees Celsius, whereas in lid B, they reduced by just 7.5. With this, you will get 2 marks. It's a 2 mark question, so that justification is important to get both 2 marks correctly. Next is Suggest a change to the apparatus that produces a greater difference between the rate of cooling for lid A and lid B. Explain why the change provides a greater difference. So you want a greater difference, whether it's lid A or lid B, you want the cooling to increase. So what can be introduced for that cooling to increase? That is, if you're using lid A, the difference, it should be more than 12, and if it is lid B, the difference should be more than 7.5. So how can that happen? How can we introduce that with the same lid A and lid B? There are different options. First option is either you can use a wider beaker. There are several answers for this. You can use a wider beaker, but whatever answer you write, you should write the explanation also. Then only you will get 2 marks. You can tell it. You can use a fan nearby, or anything that you come across. You can think about. You can write. So what I've chosen is, you make me, first thing that came into my mind is by using a wider beaker. So what happens? Wider beaker will ensure larger area for evaporation also to occur. So what happens? The difference in temperature or the rate of cooling will be much higher. Okay. So the change with the explanation has to be clearly written to get the 2 marks. Okay. E part of the question. Another student thinks that the cooling rate is directly proportional to the percentage of surface area uncovered. Remember the term, it is the percentage of surface area uncovered. So they are comparing with the cooling rate and the percentage which is uncovered. He draws a graph of cooling rate against the percentage of uncovered area to investigate it. Okay. So in the lid A, how much percentage was uncovered? Almost 50 percentage was uncovered. Am I right? And in lid B, how much was uncovered? 25 percentage. So describe how this graph line shows whether the rate of cooling and the percentage of uncovered surface area are directly proportional. So any quantity which is directly, any two physical quantities which are directly proportional will have a linear relationship. Am I right? So the graph would ideally look like this for any quantities which is directly proportional. So but we need to prove it. We have to describe it. So let's see how. So if the area uncovered was 0%, that is, if the area uncovered was 0%, very low, that is, it is fully covered, then what would be the rate of cooling? It will not cool down, right? Because it is completely closed. So the rate of cooling will be a very low value, closer to the origin. Am I right? It would be somewhere over here. If the rate percentage of uncovered area is very less. So now if the percentage of area is uncovered area is 100%, that is it is completely open, then it would be 100% uncovered. So what happens? The rate of cooling would be very faster. So we'll have a higher cooling rate. So point falls over here. So this again proves that it is a linear relationship. This is how the graph would look like. So you can write a statement like this to prove the same. Okay. So moving to the next one. Students in other countries are doing the same experiment. State one factor that must keep the same to obtain the similar readings. So it is actually a constant variable. That what are the constant variables that has to be taken into consideration is what they are asking. So you can write any constant variables, either the room temperature or the same quantity of water, which is 100 centimeter cube, has to be used, or the size of the beaker, anything, any one or two you can specify to get the 1 mark. Okay, one would be sufficient. Okay. So that was a 11-mark question on experimental study. Okay. So next we are moving on to paper 4. So the lowest possible temperature is 0 Kelvin. State the name of this lowest possible temperature. So what is 0 Kelvin? This is the lowest temperature any liquids can have or any fluids can have. Okay. So it is like the particles are in its lowest energy level. That is, they do not have any more energy to move around. That is absolute zero. So what is the name for this possible temperature? Absolute zero. So the nitrogen boils at 77 Kelvin. Calculate the boiling point of nitrogen on Celsius. We know that 0 degrees Celsius is 273 Kelvin. So to convert Kelvin to Celsius, you just have to subtract that Kelvin value by 273. So you'll get around minus 196. This is the boiling point of nitrogen and in Celsius. Next question. The temperature of a fixed mass of gas at constant volume changes from 300 Kelvin to 400 Kelvin. So the gas has a constant volume, but the temperature is changing from 300 to 400. State and explain in terms of particles the effect on the pressure. So again, this goes in accordance with the Gay-Lussac's law. State and explain in terms of particles the effect of the pressure on the gas. So what happens as the temperature is increased? What happens? The increase in energy happens. So what happens because of the increase in temperature? The pressure increases due to the increase in energy, and as they increase energy, they collide more often and more frequently with greater energy, so the momentum of the particles also increases. So you can write an explanation: the increase in kinetic energy causes the particles to collide with each other and the walls with greater force, resulting in more momentum of the particles. So it is a 4-mark question. That means the marks would be distributed with 2 mark on the for the statement and 2 marks for the explanation. So you should not simply write the pressure increased on the statement. You should you have to write a statement due to the increase in energy and momentum, and you can explain that as well, how the energy increases and how the momentum of the particles increase in this explanation part. Okay, so moving to the next question. A sample of gas is at a pressure of 120 kilopascals. The volume is doubled at a constant temperature. Calculate the new pressure of the gas. So it's a relation between pressure and volume. So we know that this is in accordance with Boyle's law, right? So as a pressure is a sample of gas at a pressure of 120 Kelvin, sorry, that has a pressure of 120 kilopascals, and when the volume is doubled, what is the new pressure? So there are two ways to solve this. I'll show you a simulation as well. So what happens over here? So this is a simulation initially when the volume was around 3 liters. So what happens to the pressure? The pressure is 1, as you can see, the pressure gauge. The pressure is 1. So now if I'm increasing the volume, that is I'm doubling the volume. So I'm doubling it to 6. 6 means how much would be the pressure now? It has reduced to 0.5. So what can we conclude? When the pressure is, when the volume is 3, the pressure was 1 atmospheres. But as the volume is doubled, so what happens to the pressure? It has reduced by half. So they are inversely proportional. And this is in accordance with the Boyle's law. So pressure and volume is inversely proportional. So we can solve it in two ways. One is by brute force, by mathematical calculations. P1 V1 is equal to P2 V2. You just have to solve it and you will get around 60 kilopascals. Another way is by logically thinking. If the as you had seen in the simulation, the volume is doubled, so the pressure has to be half. So it would be half of 120 kilopascals, which would be 60 kilopascals. This way also you can do it. Okay. It's a 9-mark question. So make sure to solve show the calculation in total. Okay. Sorry, it's a 2-mark question. So make sure to show this relation and the calculation. Okay, totally 9 marks for this particular paper for question. Okay. Moving to the next question. Figure 2.1 shows an electric tumble dryer used to wet clothes. So it is mentioned, this is your drum, and this is the air which is passing out from the drum to the condenser. Condenser has some water over here, and from the condenser cool air is moving out through a heating element, and that heating element is air is blown into the drum. Okay, so you understood the setup. Okay, so let's read the question. Hot air blows into the drum. Okay, this is the hot air they are talking about. It blows into the drum. The air gains water vapor from the clothes. So this hot air gets in water vapor from the clothes and then leaves the drum, and it leaves the drum. The moist air enters the condenser. So condenser basically cools it down, right? The cool air leaves the condenser. So in the condenser, it is a cooling part that is happening. The moist air is cooled down. Okay, leaves the condenser. Passing through the heating element, enters the drum again. It again gets heated up. The cooler again gets heated up as it passes through the heating element and enters the drum. And this process continues. State the process by which hot air removes water from the wet clothes. So this process, what is happening inside the process? What happens when hot air is passed across wet clothes? The clothes get heated up a little bit. So what all the water content in that clothes will be changing its state because of the heating element. So what is that happening? They get evaporated. That's how this hot air gets moist as it passes out through the drum. The air is cooled as it passes through the condenser. This moist air is again cooled as it passes through the condenser. Describe and explain one way in which the air leaving the condenser is different from the air entering the condenser. So the air entering in the condenser is a moist air, it is hot. So in the condenser, what happens, it changes its state. Air is much drier. The air which is living through the condenser is drier, because in the condenser it causes the water vapor is condensed back into its liquid state in the condenser. That is what is seen over here. So the air is changing its state, that the moist air changes its states, and to form the water vapor is condensed back into water, and what leaves is dry air. So that dry air is again moved through the heating element. So it's a 2-mark question, so it has to be 2 statements clearly mentioned. Next part of the question says, the drum of the tumble dryer rotates, lifting up the wet clothes when they fall down through the hot balloon. Name the force, hot air, sorry. Name the force that causes the clothes to fall down. So obviously it would either be the weight, you can mention the weight of the clothes which causes it to fall down, or the gravitation force. Either one is correct. Then, when the drum rotates too fast, the clothes remain intact with the walls of the drum. State the direction of the resultant force on the clothes during circular motion. So when it is in circular motion, what happens? The clothes stick to the wall of the drum. So the direction of the resultant force, any object which is in circular motion, what happens? Uniform circular motion, it will have a velocity in the direction of motion, and the force will be exerted in perpendicular to the direction in which it is moving. So the direction of force will be perpendicular to the direction of motion. Suggest why using a clothesline to dry clothes is, in the open air, is better for the environment than using an electric tumble dryer. So in open air, what is it? We are using solar energy and wind energy, which are renewable sources of energy. Whereas in the dryer, what is happening? We are using electrical energy, which is non-renewable, and it contributes to carbon emissions. Okay, so it's a 1-mark question. So in briefly, you can mention. So next question is paper 4. A cooking pan contains water, and figure shows the pan on a hot plate of copper pan. Okay, it's a copper pan. So copper is a metal. The thermal energy is conducted through all the solids by lattice vibration. Describe one other way in which the thermal energy is conducted through copper. It's a 3-mark question. As we had discussed in the very first question of this particular video, metals often have free electrons available for conduction. So you can mention that, or you can also mention electrons always, or the energy is always transferred from high energy particles to low energy particles, and the electrons, these gain in those thermal energy from the hot plate, which is being transferred to the low energy particles, and the free electrons also part you can mention. Anyway, there should be 3 sensible points to give an explanation to this particular question. Okay, it is not about lattice vibration or conduction, it is one other way. Okay, it is about the electrons. So moving to the next part of the question, the outer surface of the cooking pan is kept clean by regular polishing. Explain one other advantage of keeping the surface of the pan shiny. So a shiny surface are actually poor emitters of heat. So the heat will be trapped around that particular area, keeping the pan hot itself. So you can write shiny surfaces are poor emitters of heat, so heat loss will be less from the pan to the surroundings. It's a 2-mark question, so you can mention 2 points. One is about the poor emitter. Shiny surfaces are poor emitters, so because of the poor emission, what happens? Heat loss will be less. That's it. Then next question, the thermal energy passes into the water through the base of the pan. Identify the main method by which thermal energy is transferred through the water. So what is it? So when the base of the pan is heated, the water molecules in the bottom of the pan gets heated up. So as it gets heated up, what happens? It rises up. Am I right? The energy is transferred to lower energy particles, and it goes on. So what is this method? Convection. So I hope it is clear to you. If you like my content, if you like the way I'm describing each questions or explaining each questions, please like, share, and subscribe. Thank you.